All right, Geo students, it is about that time for us to move to section 8.2. So we finished up some topics from chapter 5 about the Pythagorean theorem and special right triangles, and now finally we're getting to chapter 8, trigonometry. Okay. So this page will be like a brief introduction to trig, and then we'll get a little bit more into why we use it and kind of the setup of it in this video today. Okay? So a trig ratio is a ratio of the sides of a right triangle. Very important that we're talking about right triangles here. All right? And then one very specific trig ratio is called the sine ratio. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. All right, so when we're looking, and you'll notice here, when we're looking for the sine, we use the three letters sin. Well, if I want the sine of angle A, which is right here, angle A, I need to look for the length of the leg opposite of the angle. Well, opposite of angle A is side A, so I'm going to put A, and then divided by the length of the hypotenuse, which would be C in this case. All right, so A over C. If we wanted to change this angle and talk about angle B instead, right, if I made B my angle, well, now the opposite leg has a length of B, and then the hypotenuse is still C. All right, so what's really important is that we make sure that when we're looking for sine, we're always using the opposite leg and the hypotenuse. All right, now we have other ratios. The next one that we're going to talk about is called the cosine. All right, so the cosine of an angle is the ratio of the length of the leg, and we use the word adjacent, and I'm going to say right next to it, it's next to the angle, to the length of the hypotenuse. All right, so now when I look for the cosine of angle A, well, cosine angle A, here's my angle, I now need to look at the leg next to angle A. Now be very careful. There are two sides that are next to angle A. Only one of them is a leg though, right? B is a leg, C is a hypotenuse. So I need to use the leg adjacent, which means I'm going to use B, and then I'm going to make a ratio or a division fraction bar over the hypotenuse. So B over C. What happens on the next one? Well, now if I change my angle to angle B, I'm looking for that leg adjacent, which means I have to use A because C is not a leg. So I have to use A and then divide by C. All right. The third ratio, we call it the tangent ratio. Excuse me. And we say that the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent. All right. So when we're looking for the tangent of angle A here, we first need to look and find the leg opposite. So opposite across from it, I'm going to say is A. Now the leg adjacent, we have to make sure we pick the other leg, so not C, but B. And then when we come over here and we take a look at the tangent of angle B, excuse me, oh my gosh, the leg opposite of it will be B, and the leg adjacent, of course, will be A. Okay? So understanding these three ratios will be helpful. There's some tricks that we'll learn in a little bit. But before we get there, let's talk and review just a little bit. All right. So I'm not necessarily going to do these problems, but we're going to talk through it. And So, understanding why we have to use trig. I would not need to use trigonometry in a situation such as option 1 down here. I know that I have a right triangle. I know that I already have two sides. And if I have two sides, well, then I can always just use the Pythagorean theorem to get the third side. Whether it's a leg or a hypotenuse, it doesn't matter. If you have two sides, you can get the third. Now in options 2 and 3, a little bit different. I only have one side, but I have very specific angle markings, right? I know that this is 45, 45. So all of those tricks and calculations that we did the last couple of days, they can work here, right? I know that the legs have to be congruent, so I know y is 9, and then I know that the hypotenuse, I could either set up the proportions, or I could remember my trick that my hypotenuse is always a leg times square root 2. So I could get that pretty easily, right? I mean, kind of the same thing in number 3, a little different, because I'd have to use the 1 square root 3 2 method. But if 18 is the hypotenuse, then I can put 18 here, and y is across from the 30, and x is across from the 60, right? So I could solve for y and x just by using my proportions. Now, when we come down to the bottom, this kind of hopefully, well, no, this should introduce trigonometry pretty well. All right, if I give you a picture like this, where I give you one side length, one angle that, notice, is not a 30, a 60, or a 45. Well, this is why we need to use trigonometry, okay? So, we cannot use Pythagorean theorem because I do not have two sides. Okay, please make that recognition. I can only use the Pythagorean theorem when I have two sides. We cannot use 45, 90s or 30, 60, 90s. Why? Because this triangle is a, well, let's see, it'd be a 35. If this is 35, then I think this would have to be, yep, 55. Because this triangle is a 35, 55, 90. We don't know that pattern, okay? Excuse me, oh my gosh. So yeah, we can't use the Pythagorean theorem because we don't have two sides. We can't use 45, 90s or 30, 60, 90s, well, because it's not either of those triangles. This is a brand new, different type of triangle. And so we would have to use trigonometry here to help us solve. Now, we're not going to really do that today. Today, we're really going to focus on the setup, and then in the next video, we will work on the solving. So here is kind of a phrase that I want you to start to commit to memory. And it goes a little something like this. Oh, you can't see what I'm doing. My bad. So I put an S. Okay. Now, this is read Sohcahtoa. 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 That is something that you need to memorize. This is something that I would basically rate it on the top page of every single assignment, every single assessment, anything that I'm doing for the rest of this chapter. I would probably use Sohcahtoa so that I remember that the sine, right, sine is the opposite leg over the hypotenuse. Oh, I didn't need to put another H there, but whatever, it'll work. Okay, opposite leg over hypotenuse. So then I know that the cosine is the adjacent leg over the hypotenuse. Please also just remember, adjacent means what? It means next to. And then lastly, toa, or tangent ratio, is the opposite over the adjacent. Now notice, I went from actually writing out adjacent leg to now I'm just going to call it the adjacent, right? I know that adjacent means next to, so I don't really necessarily need to always say leg and leg. Whenever I say opposite and adjacent, that means the legs that are across or next to the angle in question. Okay? So let's see how this works. Excuse me. Sine of A. Well, the sine of A means that I need to, well, pick angle A, maybe mark it so I know where I'm looking. And sine, if we go back up, means that I need to find the opposite leg and the hypotenuse. So you know what I would even do from the get-go? Now that I know I'm working off of angle A, I'm going to mark my picture up with O, A, and H, so I know exactly what I'm looking for. Well, if this is angle A, opposite or across from it is the 5. A, or adjacent, the leg that's next to it would be this one right here, right? This is the other leg. And then, of course, then across from the 90 is my hypotenuse. And this, guys, is something I would, again, strongly consider you do, or strongly encourage you to do all the time. Because now, if I remember my Sohcahtoa, this fraction setup should be really, really easy. Sine is O over H, opposite over hypotenuse. So O over H, 5 over 13. Cosine of A over H, right? A over H. So 12 over 13, right? I just find my A, I find my H, I put them in fraction form. Tangent. We set up above, opposite over adjacent. So I look, my opposite leg is 5, my adjacent leg is 12, and I'm good to go. Now some of you might be wondering, but what the heck is going on, Mr. R? Alright, and this is what I want to explain. Really, this whole idea of sine, cosine, tangent works because of everything we've just been doing. Similarity. Alright, let me, just for the time being, I'm going to call this A prime, B prime, and C prime. Alright? And let me give you some new measurements. What I'm going to do, I'm going to take every single measurement and double it, right? So if this is 10, 26, oh, I didn't double that one, 24. Well, what's going to happen if I do the exact same exercise but with A prime? Alright, if I use A prime as my angle, well then this is my opposite, my hypotenuse, my adjacent, and if you notice, when I go and I take the sine, well, I'm going to do opposite over hypotenuse, 10 over 26, but when I reduce 10 over 26, right, if I take out my calculator, (10 over 26), I get that 5/13 again. Alright, so the idea here is that no matter what, if this angle right here, I don't know, let's say it's 20 degrees. Well, this angle that's 20 degrees, it's always going to have the same sine measurement. The fraction, or the ratio of the opposite over the hypotenuse will, no matter what, always be the same value. Alright, just like we did here. These two angles were congruent. But when we do 5 over 13 or 10 over 26, we get the exact same fraction. We get the same value for the ratio. And that's what makes trig work. Whoop, wrong button. Okay. So let's finish up a couple of these, and then we will... Oh, actually, we'll have one more thing to do, and then we'll call it a day. All right. So let's take a look at number 2. Same concept. We're working off angle Z, so I'm going to mark angle Z, and then of course then I can mark up my triangle. Across from the right angle is my hypotenuse. The side, or the leg across from Z, will be my O for opposite, and the leg next to will be the adjacent. So now I know that I can write all of these ratios. Well, sine, we learned O over H, 21 over 35. One thing I strongly encourage you to always do is try to reduce your fractions. 21 over 35. Hey, 3/5, nice. Okay, so always reduce your fractions. The cosine of z, or the adjacent over the hypotenuse, will be 28 over 35, which then again, when we try to reduce, should be 4/5. Yeah, 4/5. And then lastly, tangent, opposite over adjacent. 21 over 28. You guys might be able to do this in your head, but whatever, just however you get it, just make sure you're right, is 3/4. Okay? And so these are the answers I'd be looking for. On a quiz or a test, you would lose some points if you did not reduce your fractions. Okay? So you always want to reduce your fractions. All right. Let's do one last one, number 3, and then we will move on to kind of recognizing which trig ratio you need to use. All right. So sine of angle D. Here's angle D. I know my hypotenuse is across from the right angle. I know that my opposite in this case is going to have to be across from angle D. So there. And then lastly, adjacent. It's the same exact thing, guys, okay? Sine of D means that I would have to take the opposite over the hypotenuse. So 6 square root 2 over 9. That's going to reduce because 6 over 9 is 2/3. Okay, so this is going to be 2 root 2 over 3. That looks good. Now my cosine is adjacent over hypotenuse, right? So Sohcahtoa. So a over h, 3 over 9. Well, that just reduces to 1/3. Lastly, tangent, opposite over adjacent, toa. So opposite over adjacent, and please recognize you can reduce this fraction either with your calculator, in your head, whatever, but this is 2 root 2. And so those are the answers I would be looking for. Okay? Okay, last little thing. I know this is getting a little bit long, but I do need you guys to understand and hopefully recognize, or start to learn how to recognize what trig function you need to use. And so that goes a little something like this. If in a picture I give you this 53-degree angle, excuse me, well then I want to mark up my picture from this 53-degree angle, which means that I have to mark the hypotenuse. I would probably want to mark the opposite, and I would probably want to mark the adjacent. If I'm trying to solve for this unknown side, this hypotenuse in this case, it's the h, well that means I need to use a trig function that uses the hypotenuse. So which one of these does it get rid of? Okay, I already know I'm not going to be using toa. I know I'm not going to be using toa because if I want the hypotenuse and the hypotenuse is not part of that ratio, well then that's not going to be any help. So I know I'm between sine and cosine, and then hopefully you can make the recognition that if you have the adjacent leg, well then you're going to want to use the ratio that it involves that known side. So adjacent, hypotenuse, I come back up, that means I'm going to use cosine. Alright. Another way to think about it, I didn't have the opposite leg here, right? If I don't have the opposite leg, then I can't use O, which means I can't use sine and I can't use tangent. So either way you look at it, whether you kind of figure out what you have or what you don't have, you will get to the correct answer. Once again, I look at my angle, 59. I know that 12 is my opposite. I know x is my adjacent. I know h is my hypotenuse. And so either way you look at it, whether you look at what you do have, which is O and A for tangent, or you look at what you don't have, which is hypotenuse. So you can't use sine, you can't use cosine. You know that you have to use tangent. Alright, let's do 2 more, then we'll call it. Okay, 58 degrees. Across from the right angle is my hypotenuse. Across from the 58 is my opposite leg, and then the leg that's next to it is adjacent. Okay, so I have opposite. I'm looking for hypotenuse. OH, sine. Last one. 67 degrees is right here in this corner. Across from the right angle is my hypotenuse. I have the leg that's next to 67 degrees, or adjacent. I do not have the opposite leg. So A and H, I come back up, A and A, oh, cosine. All right? So, we will stop there. I would strongly encourage you to try the last few of these on your own, just to see how you're doing. But yeah, that should be it for the first video on trigonometry. Hopefully you guys are understanding this concept of Sohcahtoa. Sohcahtoa. It's going to be pretty important. All right? Have a good day.